Okay, as we finish up our discussion on convection and density, we're going to look at a couple of the questions that we put up on the board here. What's the relationship between layering of fluids and density? If two solutions have equal volumes but differ in masses, the one with the greater mass is denser. The solution with more mass will sink or stay below the solution with less density. The next one here. How does heat affect density of fluids? As matter heats up, it expands, causing the matter to become less dense. When dealing with fluids, gases and liquids, that means it will start to rise. If the temperature begins to decrease, then they will start to contract and shrink. And the last question here. How do gases flow in the atmosphere? Gases in the atmosphere flow due to convection. Convection is the circulation of fluids that results from energy transfer. Relatively warm air masses will rise, and relatively cool air masses sink. And that also applies for liquids as well. This also will create high and low pressure areas, and wind always moves from areas of high pressure to areas of low pressure. The lab that we went over in class had to do with convection currents. And with those convection currents, we got this convection chamber, and we see we had the smoke come into the chamber, and it then started to circulate around the chamber. It received some heat from the flame here, and caused that smoke to go around in a circle. So here is the actual lab. Okay, we can see the ice here is cooling off the incense smoke as it enters the chamber, causing it to sink down right here. As it sinks down, it then moves across the bottom. As it moves across the bottom, it gets warmed up here by the candles, becomes lighter, less dense, and begins to rise. It then moves across the surface of the top of the container back over to the ice, where it cools back down, begins to sink, and the cycle keeps repeating itself over and over again. So as we look at the different questions about that, okay, explain what happened. Explain how convection currents occur in the chamber. Smoke was cooled. As it entered the chamber, it sank because it was denser in the chamber, moved across the bottom towards the candle, where it was heated, became less dense, and began to rose to the cover. And then as it moved over, it came near the metal cover with the ice. It cooled, became denser, and sank. Don't forget that we're almost essentially creating a high pressure system here, where the air is very, very cold and dense, and then we're creating a low pressure system over here by the candle, where the air is less dense and begins to rise. So we get that movement of air going across, almost like wind, from a high pressure area to a low pressure area. And then with the second question here, explain how heat transfers in convection cells on Earth. Solar radiation heats the surface of the Earth, both the water and the land. The air above the surface is heated by conduction and radiation from the surface. The warmer air expands and becomes less dense. The cooler air sinks and pushes the warmer air up. As the warm air rises, the molecules start to slow down. The air cools, the air contracts, and becomes denser. The denser air sinks back to Earth, where it can be warmed again and again. That's a continual cycle that keeps taking place. One other thing that I wanted to point out was, as we start to look at convection, we can look at this diagram here. When we turn on the heating coils, heat will start to transfer first in the air. Okay, we can see that the air will warm up and it will start to rise. As it then gets further away, it will cool, sink back down. And even above the pot, the warm air will start to rise, it will cool and sink back down. And then inside the pot, we can see that the warm water at the bottom will start to rise up, it will start to cool and sink back down the sides. And that is convection as an energy transfer, so that warmer, less dense water will start to rise. As it gets to the surface, it becomes cooler, denser, heavier, and sinks back down, then gets warmed back up and rises again. We can see that in the environment. Okay, the air near the surface, like we talked about before, will warm up. rise, become less dense, and then as it becomes denser, it begins to sink and it creates that cycle or pattern or flow. Okay, we see we have a little video here that's going to also go over convection, and we're looking at some hot water in the center here, and we have some room temperature water. We have some blue ice cubes. As those blue ice cubes melt, they are creating denser, heavier water that's sinking down to the bottom. And then we could see as it reaches the warmer area here where the warm water was poured in, it's heating up the water above. And as we add in some dye, we can see that where the warm water is causing the water to warm up and rise, creating a convection current on either side. So we see the colder blue water coming in contact with the reddish purple water there starting to rise on both sides. And it creates that convection cell, if you will. Very similar, like it says in there, to the way that wind moves on Earth. So we have the area of high pressure or low pressure here as it starts to rise up in the areas of high pressure, and it starts to move across the surface there. And that will move air masses on the Earth. Okay, and that wraps up our conversation here on convection and density as a form of heat transfer. If you have any other questions, feel free to stop by in class and ask.